Hey guys, and welcome back. Today we have a brand new DIY battery kit from Gobel Power. This is the Project X1. It's designed for single stud 280 or 314 amp hour lithium iron phosphate cells, such as the popular EVE MB31. There are two things that really caught my attention with this particular kit. Number one, I like that the case is transparent, allowing you to see your cells. And number two, I like that it holds the cells in the upright vertical orientation. We're going to run through the full assembly process here today. To get started, let's take a look at the included components. We've got our battery cages. There are two of them. There's one. Here's the second. We've got our bottom plate. We've got a top plate that holds the BMS and the circuit breaker. We've got brackets for above the cells that contain the PCBs and the balance leads. We have some epoxy board insulators for the balance lead brackets, and we have some insulative pads here for the cells on the metal cages. Epoxy board separators for the cells, a full JK BMS kit, BMS display, caster wheels, bus bars, one bag of terminals and terminal covers, one bag of cell bus bars, BMS balance harness, one hardware assortment tray, communications cable for the BMS, one Chint double pole, looks like a 100 amp DC rated circuit breaker. And lastly, out of camera, we have two very large plexiglass covers. We're going to begin by installing the casters on the bottom support bracket. You will need the Phillips screws that look like this. All right, there we go. Next, I'm going to start constructing these cell packs, and both of these frames look exactly the same, so I don't think it matters which one is on top. For this project, I'll be using a set of EVE MB31 cells. These are 3.2 volts, 314 amp hour lithium iron phosphate cells. These are not from Gobel, though they do sell lithium iron phosphate cells if you need to purchase some. I had these left over from another project. So I'm going to start with the adjustable plate thing on the right side of the cage. I have the two pieces of insulative plastic here. I'm going to bend them at a 90-degree angle and put one in each of the brackets like so. Next, I'm going to take a sheet of epoxy board and put it on the left-hand side. I am orienting the first cell with the positive facing toward me. So the positive is in this direction, and that's going all the way on the left-hand side. And then I'm just going to place these epoxy separators between every cell and alternate the polarities. So next cell, epoxy board, next cell, epoxy board, cell, epoxy board, cell, epoxy board, cell, epoxy board, cell. Before I install this last cell here, I'm going to put this end plate into place. You see there is a notch here on the side. The notch will point down and it will go in this orientation. So I'm going to put that in place. Epoxy board, very carefully slide in the last cell, and then don't forget the last epoxy board between the end plate and the last cell. That is beautiful. Look at that. Now there's actually a lot of space left in there. It really looks like maybe a little more than 1/4 of an inch. So I'm going to slip in one of these insulative pads here. It's just a piece of foam. Next, I'm taking 4 of the large black cells, and those will thread in. 1, 2, 3, 4. And what these are going to do is apply pressure to this plate to hold these cells, fix them into place. I'm going to drive them in first with a 12mm socket. So I drove those in with my drill and the clutch on the lowest setting, a 1, and that seems to be a perfect amount of tension. So I couldn't find any specific torque from the manufacturer or anything of that nature, but the way I put them in there, these cells are fixed into place. They're not loose, but they're also not tight, such that I can still, wiggle one out if I had to. Next, I have one of these fiberglass covers I'm going to place over the top of the cells, over the vents, and I am ready for the bus bar. Now for the bottom pack, I'm going to use the bus bar labeled 1155B. This also has cells B9 through B16. So this positive terminal on the bottom left will end up being the main positive of the battery, making these cells 9 through 16. And I'll be orienting that with the connector facing to the left, or the main positive cell. To secure that down, I'm using 4 of these screws that look like this. These are the bus bars that came with this kit. They are rigid bus bars. I would have strongly preferred flexible bus bars, but I do like that these ones have a hole in the center for the balance lead, and these bus bars are 1.9mm in thickness. So I'm going through and very carefully placing my bus bars. Again, this is the main positive, so this one will not receive a bus bar. The first one will go in the back, and the next one will go between cells 2 and 3, and so forth. And we've got some serrated flange nuts included with this kit to hold the bus bars down to the cells. According to a data sheet that I found online for these cells, the maximum torque on these posts is 6 Newton meters or 53 inch-pounds. For the balance leads to the bus bars, we'll need these very tiny screws. And I'm holding the ring terminal down as I tighten the screw to prevent it from spinning and messing up the wire. And I think that concludes the construction of the first battery pack. Alright, so with the second pack, I am again starting with the tension plate here on the right. So I'm going to begin my cell lineup there on the left. So I've got the same epoxy board insulator for the top of the cells, and the next PCB bar here, which again is part number 1155A for the top, and this is for cells A0 through A8. And next we're ready for the bus bars. The first one will be placed on the front left two cells, and then we're going to go from there. I'm going to switch over to the BMS assembly here for a little bit. So first I have the communications board here, and there are 2 red cables and 1 ribbon cable that need connected on the bottom of the communications board. So the communications module will go on the top here, and I'm using 4 of the same small screws that the balance leads use to secure this down to the top plate. The BMS board will be positioned on the remaining 6 standoffs, but before I do that, I'm going to route these communications cables neatly under the standoffs to the left-hand side, and then position the BMS like so. The BMS will be secured with the 6 long, thin screws. Next, I can go ahead and plug in the 3 communications cables. For the circuit breaker, we'll face the Chint logo toward the front, so it's going on the bracket like so. I'm then taking 2 of these little tabs here and putting them in the main terminals. Guess I should have done that part before I put it on the bracket. So let's put the remaining 3 tabs in, then we'll put it back on the bracket. With all 4 tabs installed, let's place it back on the bracket again. Taking the bus bar that has 2 90-degree bends in like you see here, 2 of those terminals will go on the BMS and 2 will go on the circuit breaker. On the BMS side here, we'll use these 10mm serrated flange bolts. On the circuit breaker side, we'll use these larger 13mm bolts. On the left-hand side, there are 2 threaded studs. We'll thread the insulators on those studs with the hexagonal part down. In this little box, we have a 250 amp Westing fuse, West King fuse. So 150 volt DC rating, 200,000 amps interrupt current rating. And that will sit on top of these standoffs, again with a 13mm bolt. And I'm just going to thread those on loosely because obviously we don't have our bus bars connected yet. Minor correction here, when I attached this bus bar to the BMS, I used these screws in the plastic case, and I should have used these screws that were hidden in the BMS box. So I'm going to change those out real quick. Before I put that back on, I'm also going to attach the battery positive supply for the BMS here. There are 2 red cables included in the kit. From what I can tell, this short one is not used for anything at all, so we'll just set that one aside. And this longer red cable with 2 ring terminals on the end there will be used for the battery positive supply to the BMS. We'll reattach the bus bar here using the correct screws this time. This smaller bus bar here with 2 90-degree bends will go on the output of the circuit breaker like shown. Now we're ready to set the BMS on top of the battery pack. So this is the top battery pack containing cells 1 through 8. There are 2 holes on each side to be secured with these. On the back side of the top pack, I'm taking this bus bar that is bent 1, 2, 3, 4, 5 different times. The end with 2 larger holes will go down on the BMS. The other end will sit over the main negative terminal, but first I need to attach the final balance lead. And something I just noticed as I'm standing here talking, I have not used this bus bar yet, and there's quite a ring around there that looks like somebody else has used it before. The balance lead is now connected, and I'll just get my serrated flange nut in there. It's a little tight, but there's plenty of room. Now we're ready for the hard part, which is stacking the batteries, and this would be much easier if I were doing it on the ground, but I'm doing it up on the bench here for the purposes of filming this video. So there are 2 screws on each side, 2 bolt holes here for which 2 of the 10mm bolts will thread into to secure this whole frame to the bottom plate here. That'll be done with these bolts here. And that's looking pretty good. Just have to make sure I don't roll it off the end of the bench because that would be pretty disastrous. All right, I got the second cage of batteries lifted on top there. Same with the bottom. There are 2 bolts on each side there to secure the 2 cages together. To connect the 2 battery packs together, I'm using the bus bar that is bent like this. And here's a look at the bottom battery pack. You can see where that bus bar is sitting. And then on the back side, it goes the whole way up, and it's sitting on the positive terminal of the rightmost cell on the top pack. 1 serrated flange nut on the top, and then I have a balance lead to connect. The last bus bar to connect to the cells is the main positive on the bottom pack left-hand side. And that's going to be the large bus bar that looks like this. For the balance lead harnesses, one is quite a bit longer than the other, about a foot longer. So the longer one is obviously going to the bottom battery pack. It is possible to mix these up, and I do not want to mix these up or I will ruin my BMS. So I've connected the shorter one to the first grouping of cells, which are labeled as B0 through B8. And the longer bundle of conductors is plugged into the second set of connectors here, labeled B8 through B16. When connecting these to my battery pack, I'll be plugging in the cables of lower potential first, which is the shorter harness going to the top battery pack. I'm ready for the first balance lead, and the second, the positive power for the BMS. The positive and negative terminal post will be installed with these long Phillips screws and 4 nuts. First, I'm going to peel back some of the protective plastic. The terminal goes in from the outside, followed by the screw, and then the nut on the inside. And I'm just tightening these down by hand very carefully because I do not want to risk cracking this plexiglass. The cover will be held in with a series of these Phillips screws with built-in washers. Next up, I'll be connecting the positive and negative bus bar to the appropriate terminal, and that will be done with these bolts. Next up, we have the display, which will get mounted in the plexiglass front panel here, and I think I use these somehow, so I'm going to try to figure it out, see if I can get this connected here. Obviously, this comes in from the front, something like that. That seems a little odd there, but I suppose it's holding. There's one of those for the top and a second one down there at the bottom. So the end of the display cable, it has 2 connectors. The larger connector goes into the display. Then this button also goes on the front, but the connector is a little bit different here. I don't know, what's that? Four conductors? It looks like a 6-pin connector there. But the connector hanging off the display harness here only has 3 pins and only 2 conductors connected. However, I do see one of those conductors is black. So if I hold up the end that goes in the BMS, I can see it's the second conductor from the right that's black. And by holding up the original connector the same way, I believe it plugs into the switch like this. We'll see if it works when I give it a push. And that cable for the front display will go in this connector here. All right, the display turned on, so I guess I had that push button connected correctly. All right, so the first thing I need to do is remove the protector and then change this to English. And these batteries are fully discharged from my last battery test, so I do need to charge this battery, but you can see the highest cell is 3.14 volts and the lowest is 3.13 volts. This is a very, very nice display. And lastly, there is a plexiglass lid that goes over the top to keep dust, dirt, and debris out. There are 4 tabs that simply clip onto the side, and it does have a square hole cut in it for the circuit breaker here. There we have it, the full assembly of the Gobel Power Project X1 battery kit. There's a lot to love about this kit. I love that the case is transparent, that you can actually see your cells. Do you really need to see the cells though once it's fully assembled and put into service? Probably not. I like seeing them, and I think it allows for easy inspection. I love that it holds the cells upright. Even if the manufacturer approves laying the cells on their sides, I still feel the upright orientation is the best orientation for these type of cells. I like that the cells are held in a steel frame with the ability to adjust the fixture tension. And lastly, I like that it includes the prefabricated bus bars. There are a few things that I feel could use improvement. I really wish this kit would have included flexible bus bars for between the cells. And they are fixed in a steel case, yes, but over time there will be minor movements, there will be some slight expansion. Having those flexible bus bars just helps to reduce that tension on the battery posts themselves. And the second thing is the balance lead harness to the bottom section of batteries was just a hair too short. It really needs to be about 3 or 4 inches longer. Aside from that, I feel this is a fantastic case, and I'm actually thinking about going out and purchasing a second one myself. I'll leave links down in the video description if you'd like to learn more. As always, please let me know what you guys think, and don't forget to hit that thumbs up button on the way out, and thank you for watching.